Hello, now I will explain you how to solve assignment problem with Hungarian method. Suppose that we have 5 workers M, N, O, P and Q and 5 tasks A, B, C, D, E. And here are costs of assigning one worker to one task. The main thing in assignment problem is that supply and demand are all equal to 1 because one worker should be assigned to just one work and one task should be done by one worker. So to solve with Hungarian method, first thing we should do, we should find the minimum value of each row. So minimum value of the first row is 7, in second row is 6, here 6, 9 and 7. Now next step is to subtract this minimum value from each cell of this table. So our new table will be like this: 9 minus 7, 2, 11 minus 7, 4, 7, 4 and 0. Here will be 0, 9, 7, 7 and 4. Here 6, 7, 0, 2, 2 and 2, 0, 1, 3, 0. And here 0, 5, 7, 3 and 7. So we have found minimum values and subtracted from each cell of this table. Now we will find minimum value of each column. In this column minimum value is 0, in this also 0, third column also 0, here we'll have minimum value of 2 and here also 0. Now we will subtract minimum values from each item of column. Here first 3 columns and the last column will not be changed because minimum values are 0. Just this fourth column will be changed. So here we will just copy 0, 9, 7, 0, 5, 7, 7, 0, 1, 7. Here 2, 5, 0, 1 and 1. Here 0, 4, 2, 0 and 7. Next step, we will start scanning these rows. Firstly we will scan the rows then after scanning all the rows we will pass to the columns. While scanning we will look for zeros. If there is just 1 0 in a row, for example first row we have just 1 0, we will square it and cross out this column. Scan the row, cross the column. In second row, here also we have 1 0. Scan the row, cross the column. Okay. Next row is third row. We have 2 zeros, so we will skip this row. In the fourth row we also have just 1 0 that is uncrossed, undeleted, you could say. And scan the row, cross the column. In the last row we don't have any zeros, so we will pass to the columns. Scan this column, we have just 1 0. Scanning the column, we will cross out the row, so we don't have any zeros left. And total number of the squares is 4, but the size of matrix is 5. They are not equal, so we will continue our iteration. Next step is to update this table. This crossed out, firstly we will find the minimum value of these numbers that are left uncrossed. It's 1. You can use any one because they are all ones. Let's circle this one, circle the minimum value, and while making up this table, these numbers crossed with lines will stay the same, but numbers in the intersection, these intersections of two lines, will be increased by 2. Wait, by 1. Yeah, sorry. So let's start. 2, 0, and 6. It is in the intersection of two lines, so we will increase by 1. It will be 7. It will stay the same. Here also the same, and 7 is on intersection, so it will be 8, 0, and 5. Next, these ones, 0, 4, and 2 is on intersection, so it will be 3, and 0, and 7. These numbers also will stay the same, 0 and 0, but these numbers that are not crossed with lines will be decreased by 1. So here will be 6, here will be 1, 6, and 4. Here 0, 0, 0, and 6. So here we have new table, and let's start scanning again. We'll start from the rows. Here we have 1, 0. Scan the row, cross out the column. Scan the row, square the 0, and cross out the column. Scan the row, we have 2 zeros, skip. Next row we have 3 zeros, also skip. And last row we have 1, 0. We will scan the row, cross the column. So we have scanned all the rows. Let's pass to the columns. We are scanning this column. We have 1, 0 here. Scan the column, cross the row. And we'll scan this column. We have also 1, 0 here. Scan the column, cross the row. So total 5 squared zeros. Squared zeros means assigned work. So 5 is equal to size of matrix is 5 also. So our work is done. This is our last table. So it means that we had M, worker M, N, O, P, and Q, and works A, B, C, D, E, tasks. So M will be assigned to the E work, last work, and N, worker N, will be assigned to the A work, worker O will be assigned to the C work, and worker P to the B work, and worker Q to the D work. And so if we look on our table of costs, we obtain total cost of which is equal to M to E, this one, N to A, this one, O to C, this one, and P to B, this, Q to D is this. So if we will sum up this cost, will be 7 plus 6 plus 6 plus 9 plus 10 which will give us 38 in total. So we can write that this assignment problem will be performed by in total cost of $38.